And the first presentation is by Niall Corney from AECOM. Now the floor is yours.
So first of all, thank you very much for the invitation. It's nice again to be in this type of forum talking about sustainability. So thank you for the invitation. My name is Niall Corney. I'm the UK and Ireland Ground Engineering Practice Director for AECOM. So today's topic was really interesting to me, talking about safety, talking about savings, and talking about sustainability, and trying to reconcile all these different applications by common design. And at first I thought, you know, it's kind of interesting. Maybe quite often we have savings with sustainability. I'm a big believer in the fact that we don't have to pay more for sustainability. But then having safety involved as well is an interesting dynamic as well, trying to tie safety in. But I think what I've got to present to you is really a case study which ties all of these together really nicely. And I'm just going to take you through that case study today after a little bit more of an introduction. So AECOM, just to give you an idea of the scale of AECOM, we're a very large global consultancy. We've got just under 50,000 people all across the world, very top heavy in the US and North America, of course, but with a very strong contingent here in the UK and also down in Australasia. Just really putting this slide up to not only show that we're, you know, highly ranked as an ethical company around the world, we also have a very strong ESG commitment running through the whole company. And we're also very well connected. And one of the reasons I would put this slide up was just to illustrate this, because I'm going to be talking to you today, even though I'm based in the UK, about a project that's happening at the moment in Melbourne in Australia. And one of my colleagues in Australia has been kind enough to share some of the details on that project, which is what we'll be looking at today. So as geotechnical engineers, as ground engineers, we're very good at putting large amounts of concrete into the ground. This is what we do. This is what we specialize in. And this is where we add value to projects all across the world. But there's some fundamental truths that we need to outline as geotechnical engineers. We need to recognize that there's a correlation between the depths that we're operating in, the risks that are involved in increasing with depth, and the costs that also increase with both depths and that risk. So we need to, again, understand that 20 to 25% of any building costs are typically underground. Now that could be in deep foundations, it could be in substructures like basements or retaining walls. So when we look at sustainability, we're looking at the carbon load that's embedded within all that concrete that we're using. And we can correlate that, of course, to the volume of concrete that we use. So the volume of concrete we use, it relates to how conservative we are in our designs. I'm not talking about factors of safety. I'm talking about conservatism in adopting design parameters that we use. And that conservatism largely comes from unknowns. We tend to be more conservative when we have less information on the ground that we're building in and designing in. So ground investigation informs our design. We know that. And as the very nature of this talk, we're talking about increased testing saves money. Well, this is so true in ground engineering, because we know that the more information we have from ground investigation, the less conservative we are with our designs. Therefore, we lower our design risk, and therefore we have the opportunity to reduce the volume of concrete we're putting in the ground, and thus the amount of CO2. So this is how it all links together really from a sustainability point of view and ground investigation. There's a huge opportunity for us to be, again, more detailed, more thorough in our GI to save carbon and have better sustainability credentials, which is what we'll look at in the project that's coming up. So this is a really nice example that I uncovered, as I said, with an Australian colleague. It's based in the suburbs of Melbourne. It's a live project. I'm going to be a bit candid about who the client is and where it is and those type of things, because they're not really ready to go live with talking about this in detail, because it's an ongoing project. So if you'll excuse the fact that I'm not going to go into too much detail about who, why, what, when, where, but the general concept I think is fantastic for outlining this relationship between safety, saving money, and sustainability. It's one of the best that I've seen in the last couple of years. So there's a new ring road being built in the suburbs of Melbourne. This is a rail project because the railway line is crossing over this new ring road. The Gap Road level crossing is what we're talking about there, highlighted in blue. And the proposal is to remove that level crossing by building a bridge with the road dipping underneath it. So the baseline design that was tendered shows a multi-span bridge with 5 piers there supporting it. On either side, there's a footpath for pedestrians and cyclists to use. And then the traffic goes on the running lanes below the bridge spans, with the railway line crossing over the top. So just to draw your attention to a few things on the from a safety point of view, this is a community space. It's going to be used as a corridor through a very urban environment. The fact that the bridge piers were causing this boxed in section underneath the bridge raised safety concerns. There weren't good exit routes. There weren't good lines of sight. So we're talking about community safety here, not safety during construction. We're talking about long-term safety of the citizens of this part of Melbourne. And it was felt that these places, they were too enclosed, and that something had to be changed in the design. Other things that we're looking at was the column arrangement and the associated piers there, with the foundation piles as well underneath those supporting columns. Also between the columns, if you imagine that, there was the backfill was going to be excavated out. There was going to be a mass concrete wall poured in between the columns there to support the footpath. Imported granular material was going to be backfilled in there as well. So the extreme abutment piles were also acting as a temporary support, if you like, for excavation to bring in that granular backfill while the mass concrete wall was put in place. Now, that's a very standard design, nothing too unconventional really about that bridge, but this whole project is being supported from a sustainability point of view by the client to encourage sustainability initiatives to be put in place. And it's a really positive environment for actually generating not only sustainability, but as we'll see, safety benefits and cost savings. So the more sustainability initiatives you bring to the project, the higher the score you get, and the more score you get, the more share of the savings is split between the client and the contractor. So it's a very healthy environment to work in, and it's something that's it was fascinating for me to hear more about it from my colleague. But this is the background as to why the design was changed from that baseline design, and we'll see we'll see the key points that were made. So this is the changed bridge. This is the one that's currently being built. You'll notice that the number of spans have been eliminated. We're now down to just a dual span bridge. The reason this could be done was because they carried out further GI. So more ground investigation was done at each of the pier and foundation points, which really informed the design. So they could still stick with their 800 or 900 diameter columns and piles, but they shortened them because they had better ground information, and they reduced the number of them as well. So that was a huge cost saving in itself. We just went for a double span deck after that with the rail line running on top. But also you can see where previously we had the cycleway and the pedestrian footway was used behind another wall of piers or columns here. This is now much more open. So the lines of sight are better, the exit routes are better, there's more light getting in there. It just feels like a different environment. Also the walls, retaining walls here on either side of the carriageways, these have been replaced with shotcrete rather than excavating out and building mass concrete walls between the additional columns here. So we've got a number of instantly beneficial things have been happening here, and these can be summarized really nicely. This is part of the reporting process that's been going back and forwards between the contractor's consultants, who are AECOM, and the client. And this is really a summary of what was achieved on this project. So we had the board piles and shotcreting arrangement, and the use of these board piles and shotcreting reduced the materials usage and the requirement for soil excavation, and less equipment, less transport off-site. So the savings there, you can see in the right-hand column, we've got over 109 tons of CO2 saved and 111 meters cubed of concrete. And what's that? 12 tons of steel as well. So big numbers here from the reduction in the piles and the columns and the foundations supporting them. The next point there was the ground investigation, additional ground information that was available, which informed the design for the foundations, allowing them to be piles not to go down as deep. And this additionally saved another 500 tons of CO2. And also you can see that almost 300 cube of concrete. Now you're probably doing what I was doing and working out what that is. Wherever you are in the world, you're working out, how much you pay for 280 cube of concrete, which is, almost 500 tons of concrete. These are all big cost savings as well. And for the amount of additional ground investigation that was done, which was less than, let's convert it into US dollars to be global, it was around about 35,000 US dollars they spent on additional ground investigation. And the amount of concrete they saved in itself far exceeded that, let alone the time that's going to be saved on site and program. The other interesting thing, which I didn't highlight because it wasn't purely geotechnically related, is the glass fiber reinforced panels that clad part of the bridge. And these in themselves replaced the precast panels that had steel reinforcement in them. But the fiberglass reinforced concrete panels also had a huge saving as well there, with 65 tons of CO2. The final item here is the elimination of these two bridge piers, and this again had a huge impact on the CO2 and also the concrete. And you can see there again, adding it up in your head, these are big numbers. This has made a huge difference, and this cost share arrangement that the client has with the contractor makes this a really positive environment to work in. It's really constructive. it's cross-party. Everybody has a benefit in achieving not only sustainability, but making cost savings. And in this particular solution, we have this great ability to create this new sort of urban environment here, where you have a very attractive space here that encourages people to use it. It can be used for pedestrians without fearing that they're going into some dark enclave there underneath the bridge. So all in all, it's been a really positive project, and I think it emphasizes how we can actually pull all these factors together. We can look at having better GI available to us. That informs our design. It makes our designs more optimized. There's always going to be a saving in there from a sustainability point of view if we can optimize the design from the baseline. But this one also, the driving factor behind it was this community safety that was very necessary in this part of the town. And to be able to achieve all three things in the same project, I think just exemplifies how it can actually be brought together. You can reconcile those three attributes by design in most projects. And I think a lot of what we need to do in engineering comes a lot from common sense and joined up thinking. And this really is just a fine example of that, I think, in this case. And I need to give thanks to my colleague Grant Violin down there in AECOM Australia for sharing this information and allowing me to talk about this project in very broad terms. And I know it'll be a more detailed project that'll be discussed in the future, but I hope that's all been of interest to you.
Yeah, thanks, Neil, for a very interesting presentation and a very interesting project.